You are now muted.
Okay. Okay, let's wait for 1 more minute, then we'll start, okay? Today we'll start with transformer, no? Yes or no?
Sir, you gave exercise 10B question number 7 as homework.
Yes. Any problem with that?
So can you explain subpart C of that?
Okay, 1 minute. Okay, exercise 10B, which one?
Number 7.
Exercise 10B, which one you said?
Number 7.
Okay, 1 minute, okay? Exercise 10B, number 7. Okay. Now, which part you said? 7C. Yeah, when will the couple acting on the coil will be maximum and minimum? Now, see, what do you mean by couple? Tell me. Couple means two equal
forces, opposite direction.
opposite parallel forces not acting on the same line. Correct. So in a rectangular coil, if you see, if this is the rectangular coil, this is the magnetic field. Now, see, we know that these are the arms A, B, C, D. So, see, in the arm CD or AB, see, if in the arm AB the force acts inwards, in the arm CD the force will be acting in which direction?
Outward.
Outwards. So, both the forces will be equal or not, because it will be acting on the same rectangular coil?
Yes, sir.
Correct. So one force is acting inward and another force is acting outward. That means it forms a couple or not?
Yes, sir.
Yes, sir.
So if it forms a couple means, when is the couple acting on the coil will be maximum? When the plane of the coil is parallel. When the plane of the coil is parallel to magnetic field, couple acting will be maximum. And when the plane of the coil is perpendicular to the magnetic field, it will be minimum or not?
Yes, sir.
That is the answer.
Understood, sir. Thank you.
Okay. Because see, if you remember, I told you the force acting on the coil is maximum when the plane of the coil is parallel or not.
Yes, sir.
And the force acting on the coil will be minimum when it is perpendicular to the magnetic field or not.
Yes, sir.
So same thing, force, but over here they have given the question in terms of couple.
Magnetic field.
No, force and couple, what is the only difference? Whenever we consider one force, then we say it is force. But when we consider two equal and opposite parallel forces, we consider what?
Couple.
Couple. That is the only difference. The force is maximum when the plane of the coil is parallel to the magnetic field. So couple will also be maximum when the plane of the coil is parallel to the magnetic field. Clear?
Yes, sir.
Okay. Anyone any problem? Anyone any problem?
No, sir.
Okay. Now, so today we are going to start with a new topic, that is transformer. Okay. Now, transformers, if you see, transformer means, okay, it is a device, okay, used to, increase the AC voltage or decrease the AC voltage. Okay. So, transformer is a device used to increase the AC voltage or decrease the AC voltage. Now, a transformer see, there are two types of transformers. So one which increases the AC voltage, one which decreases the AC voltage. Okay. So a transformer which increases the AC voltage, okay, and decreases the AC current. Transformer which increases the AC voltage and decreases the AC current is known as step-up transformer. Okay, and a transformer which decreases the AC voltage and increases the AC current is known as what? Step down transformer. So basically there are two types of transformer. One is a step up transformer, one is a step down transformer. So as I said, okay, see in a step up transformer.
Stars copying.
Okay, 1 minute. I'm just repeating the same thing. I'll repeat the same thing. Step up transformer step-down transformer. In a step-up transformer, as I said, it is a transformer which increases the AC voltage.
AC voltage.
Okay? But it decreases the
Decreases the AC current.
AC current. Now I'll tell you the reason also why. Okay, wait. Now, step-down transformer
decreases
decreases
the
the AC voltage and increases the
AC current.
AC current. So this is the main difference between a step-up and a step-down transformer. This is how we classify step-up and step-down transformer. Clear?
Yes, sir.
Okay. Now, if we go to the construction of a transformer, okay, okay. So now if you go to the construction of a transformer, see, transformer mainly consists of three important things. Okay. One is known as core of the transformer. Okay. Core of the transformer. Okay. And the next one is primary coil. Secondary coil. Okay. So a transformer consists of these three important things. Core
So
of the
there will be two coils.
Yeah, two coils. Core of the transformer, primary coil and secondary coil. Okay. Now, primary coil, okay, is the place where we put the voltage which has to be stepped up or a step down. That means input voltage is put in which coil?
Primary coil.
Primary. Primary coil input voltage is put
So
in.
input volt. What do you understand by input voltage?
Input voltage means suppose you you have 15 volt, a device which gives you 15 volt. You have you have a source which gives you 15 volt potential difference, but you require 240 volt. So this 15 volt you will put in the primary coil, and from the secondary coil you will get how much?
240 volt.
240 volt. If it is what kind of transformer?
So
Step
step
up.
up.
Step up transformer. Okay, so this input voltage over here will be how much?
15 volt.
15 volt. That means the voltage which you want to step up or a step down, that has to be put in which coil?
Primary coil.
Primary coil. And the voltage after getting either stepped up or a step down, the voltage which you receive in the voltage which you receive, that will be coming out from which coil?
Secondary coil.
That will be coming out from the secondary coil. Is this clear?
That means it is the output voltage.
Yes, the output voltage you will get from secondary coil. Clear? So input
Yes, sir.
voltage you have to put in primary coil and output voltage you get from the secondary coil. Is this clear? Is this clear?
Yes, sir.
Okay. So if you see the construction of this now, say if this is the core of the transformer. Okay. So this is the core of a transformer I made. Suppose this is my core of the transformer. Okay. Now, so this is my primary coil. Okay, so this is, suppose this is my primary coil. So your input voltage will be over here. Okay, and this will be my secondary coil. I'm just drawing a simple sketch of it, okay, as of now.
Which is the primary one?
I'm showing you over here. This is the primary coil. This is the secondary coil. So consider the left hand side is your primary coil, right hand side is your secondary coil. So you get the output from here.
So will they be connected?
No. I'm coming to the working way. First, understand the diagram only first. Okay. So this is your output voltage. You'll get the output voltage from here. This is the input voltage. This is your output voltage. And this is known as the core of the transformer. Clear? So this is a simple sketch of a transformer. Now, I'm not saying which one is a step up transformer, step down transformer. I'll come to it diagrammatically also. First, try to understand the diagram first. Yes, no, what?
Yes, sir.
Okay. So, this is a simple sketch of your transformer. Clear?
Yes, sir.
Yes, sir.
Okay. Now, as I said, see, a transformer, it is a device that is used to increase the AC voltage or decrease the AC voltage. Correct? And the transformer which increases the AC voltage and decreases the AC current is known as step-up transformer.
So why in the definition we have not written also that it increases or decreases the current? Only the voltage we have written.
See, I have not given you the actual definition as of now. The actual definition, I'll mention it. I'm just briefly explaining you what it is actually. Okay, right now.
Yes.
Now, and a transformer in which we decrease the AC voltage and increase the AC current is known as a step-down transformer. Okay, so that means there has to be some difference somewhere to differentiate it between a step-up and a step-down transformer then in a diagram also.
Yes, sir.
Correct? So if you see over here, so diagrammatically, how do we differentiate it? Okay, diagrammatically, we have to see the number of turns in the primary coil and in the secondary coil. So number of turns, okay, number of turns in the primary coil and secondary coil. This will give us an idea about what kind of a transformer it is. Okay, so the number of turns in the primary coil and secondary coil will help us to understand the difference, means will help you to identify whether it's a step up or a step down transformer. Now why? Okay, how? Now to understand
More number of turns, then it will be a primary step up transformer. Then
now, in which one?
the more number of coil.
More number of coil in which one?
The right one.
Means the secondary coil.
Yes, sir.
No more number of turns in the secondary coil than the primary coil, then it's a step up transformer.
Yes, sir.
Okay, and number of turns in the secondary coil is less than the number of turns in the primary coil, then it is a step down transformer. Okay, very good. That is correct. But now, before I come to that, I will tell you one thing. See, what is the working principle of a transformer?
Electromagnetic induction.
Very good. The working principle of a transformer is electromagnetic induction. Correct?
Here will we use right hand rule.
Wait, coming to it. Wait. 1 minute, okay? Now, let's go stepwise, then you'll understand. So, working principle of transformer is electromagnetic induction. Correct? And we know that electromagnetic induction means whenever there is change in the magnetic field linked with the coil. Whenever there is change in the magnetic field linked with the coil,
EMF will be induced.
EMF is induced or not. This is electromagnetic induction or not.
Yes, sir.
Yes, sir.
Now, what we know is that, see, for what we have learned in Faraday's experiment is that, okay, so when a magnet or a coil moves, that means when there is a relative motion between the two coils, so there is a change in magnetic field, then the EMF is induced or not.
Yes, sir.
But if you see in a transformer, nothing is moving. The coil is not moving at all. The core is not moving. So how do we apply the electromagnetic induction over here? Okay. Now, actually over here, what we say is that in a transformer, okay, in a transformer, how do we apply the electromagnetic induction in case of a transformer? Okay. In case of a transformer, how do we apply electromagnetic induction is like this. Okay. See, a transformer works on the principle of electromagnetic induction and makes use of two coils having different number of turns. So the two coils will be having different number of turns. Suppose over here, now take an example of this, okay? First try to understand, then I'll go deep in the topic, okay? This is the core of the transformer, and one side, suppose for example over here you have less number of turns. Say over here you have only 2 turns, okay? 1, 2. Suppose this is your primary coil. This is what? The primary coil, so your input voltage will come over here. Okay? And let us see, this is your secondary coil. This is a secondary coil.
Output voltage.
You will get the output voltage over here. If you look, by looking at the diagram, we know that number of turns in the secondary coil is greater than number of turns in the primary coil.
Yes, sir. Step-up transformer.
Okay. So over here, what happens is that now if you see, okay, the 2 coils have different number of turns or not?
Yes, sir.
Okay. So if you look over here, when you when you put the input voltage over here, means the current starts flowing to this coil or not?
Yes, sir.
Correct. So when the current starts flowing through this primary coil, it will produce what?
Magnetic field.
Magnetic field.
No, that is why, see over here, if you remember, I'm saying input AC voltage. Yes or no?
Yes, sir.
Input AC voltage. So if we are talking about input AC voltage, means what kind of a current is that? AC means what? What is the abbreviation of AC?
Alternating current.
Alternating current. That means if it is alternating current, means it is changing its direction of phase periodically with time or not?
Yes, sir.
So that means alternating current means it's a varying current or not, or is the current of constant magnitude? What kind of current is that? Variable current or current of constant magnitude?
Variable current.
Variable.
Variable current.
Very good. That means when the current is flowing through this primary coil, it is changing continuously or not?
Yes, sir.
So the magnetic field lines which is being produced in the primary coil due to the variable current is also, see, so the whatever magnetic field lines will be produced over here, it will get linked with the secondary coil or not? Yes or no?
Yes, sir.
So in both the coil there will be magnetic field lines. No?
No. Over here you are not passing current, no. Over here you are passing current. No?
Yes. Yes.
When you pass
Then
current,
how magnetic field lines is produced over primary coil?
when the current flows through the conductor, what does it produce?
Magnetic field lines.
That is the magnetic effect of current or not?
Yes.
Yes, sir.
So when the current is passed through this coil, magnetic field lines will be produced by this thing or not?
Yes, sir.
Yes, sir.
So that magnetic field lines, okay, will cut through the secondary coil or not?
Yes, sir.
Yes, sir.
Now, as this magnetic field line is produced by the variable current means it is changing. It's changing continuously with time or not.
That means it is changing its polarity.
You can say polarity or strength, whatever it is. It's a variable current, no alternating current. Changing its phase, no direction.
Yes, sir.
So if it is changing in direction means the magnetic field lines over here will be changing continuously or not.
Yes, sir.
So if there is a change in the magnetic field lines, then what will be induced over here then?
EMF.
Current, EMF.
EMF will be induced in the secondary coil. Now, the EMF which is induced in this coil, if you see, now it is getting induced over here with more number of turns or not? As
Yes,
compared
sir.
to the primary coil. So as the number of turns over here is more, induced EMF will be what?
Mode.
EMF induced will be more. That means less EMF is getting converted to more EMF. That means AC voltage is increasing or decreasing in this case?
Increasing.
Increasing. So if the AC voltage is increasing in the secondary coil, means what kind of a transformer it is then?
Step-up transformer.
It is a step-up transformer. Now, see over here, EMF induced is more. That means voltage is increasing. Okay, but at the same time, if you see, as the number of turns are increasing, length of the wire is increasing or decreasing?
Increasing.
If the length of the wire increases, means what happens to the resistance of the wire then?
It increases.
Increases.
Increases. If the resistance increases means the value of current will be less or more.
Less.
So less.
If resistance increases, current will be less or more.
Less.
Current will be less. So if you see, as it is a step-up transformer, induced EMF is becoming more. That means it is increasing the voltage, but it is decreasing what?
Current.
Current. Is this clear?
Sir, how the length of the wire is increasing?
If you have 2 turns and if you have 10 turns, which wire will be longer?
10 turns.
10 turns. So if the number of turns are increasing, means the length of the wire is not increasing of the coil.
Yes, sir. Yes, sir.
Clear?
Yes, sir.
Sir, can we derive it from the relation P equals to VI?
No, P equals to VI, you cannot apply it over here because it's an induced EMF. No.
Yes, sir.
Because power in both the cases, see, if it is an ideal transformer, it has to be same. Okay, because see, power is V into I. Correct?
Yes, sir.
So, input voltage, input current. Okay. And this side, output voltage into output current. The power on both the sides, if it is an ideal transformer, the power input has to be equal to power output or not. Because we know that if it is an ideal transformer, work input will be equal to work output or not.
Yes, sir.
Because work done and energy means what? Work done and energy means what?
Same thing.
Same thing, no. And we know that energy can neither be created nor be lost.
Just transform.
But can get transformed from one form to another form or not?
Yes, sir.
Yes, sir.
Clear?
Yes, sir.
Yes, sir.
Anyone, any problem till here?
No, sir.
Okay, then we'll continue in the next class then, boys.
Yes, sir.
Yes, sir.
Okay. Good morning and thank you everyone.
Good morning and thank you, sir.
Thank you, sir.